Welcome to International Definition. My name is Kenneth Freelain, and I'm going to be your host for today's edition of International Definition. Today on International Definition, we're going to feature the engineering tribute to the Presidential Inauguration of January 20th, 2013. Today, we're going to examine a PowerPoint presentation which was prepared by an engineer named Miguel Cooper, also known as Mike Cooper. Miguel Cooper delivered this lecture during a meeting of the Mars Society, and we invite you to share your comments with us so that we can include your feedback in a future presentation. You may contact me, Kenneth Freelain, through this television station in order to share your views and your comments. So now, let's watch this PowerPoint presentation. A good knowledge of all of the elements and modules which form the ISS today is required in order to be able to select the ones that make sense for the Mars project. We should keep the functionality of the ISS in mind. We should also remember the international partners, the risks of each configuration, and the implications of reassembling the various modules. As in the case of every project, this project has several major groups of tasks which need to be addressed. Using a time frame of 11 years, from 2011 to 2022, the main groups will include the following 4 task groups. Task group number 1 will be mission planning, and you can see it here on the screen. Mission planning is the first task group, and this task group will address the planning of the mission. It will define the objectives and goals. It will develop a general consideration of hardware and people, including administration, mission control, crews, NASA and international partners, participation plans, the role of private companies, vehicle status, possible budget items on a yearly basis, etc. Task group number 2, which you can see on the screen here, that's design and definition. This task group will arrange for the reconfiguration of the ISS and MOS, that is International Space Station and Mars Orbital Station. It will define new elements, select companies to develop conceptual designs for launch vehicles, for spacecrafts, and for a Mars rover. It will organize a possible mission control team and define a mission control center on the Mars Orbital Station. It will evaluate risks. It will design the Mars exploration plan, and for both the minimum and extended missions, vehicles should be defined according to standard definitions. It will design both the minimum and the extended versions of the Mars exploration plan. It will identify the supplies and parts which need to be included in storage modules. Task group number 3, that will be assembly. This task group will locate ISS modules while building and testing new hardware. And task group number 4 will be entitled, task group number 4 will be the new hardware integration task group. This test group will test completion of the propulsion systems for the MOS, launch vehicles, crew space vehicles, Mars lander, rover, and return vehicle. It will also define a tentative schedule to launch and assemble these various components. Now let's talk about astronauts' tools and suits. This task group will design the suits to be used aboard the MOS for Mars exploration. It will design the tools needed for repair activities and for the exploration of Mars. Now you can see the additional Mars probes task group. They will consider if additional Mars probes need to be taken for atmospheric measurements before landing and for Mars observations after the crew departure. Also, it will consider what equipment may be left on Mars for unmanned exploration. And finally, you have the Risk and Emergency Management Task Group. A special group will be working on each stage to identify the risks of every phase and to develop the details of the abort and emergency plans. These major groups of tasks are divided into more specific activities. As you already know, each activity will have its own project planning. These two slides will show some of the activities which should be included in this project. I will not go into all of the details for each one of these in this presentation. It would be too much detail. Now, once again, as you can see, as in the case of the previous slide, these major task groups are divided into more specific activities. Each project plan should resemble this one. This one begins in the year 2011 and it ends in 2022. But if you can't make out the fine details, time is listed at the top along the horizontal, along the horizontal axis at the top. Whereas on the vertical axis, you can see that the activities are listed. Now let's talk about some additional elements. After the identification of the elements which may be used for the Mars orbital station, additional systems must be identified. For this presentation, 3 different systems have been identified, and you can see them. They're listed in that top row, where the first one out of 3, would be the propulsion system. And the propulsion system will be used in order to enable the MOS, that's the Mars Orbital Station, to leave the Earth's gravitational field in order to begin its journey to Mars. The propulsion system will provide course corrections and speed reduction in order to enter into an orbit around Mars. After the exploration of Mars, this component will leave the Martian gravitational field for the journey back to Earth. Route corrections and speed decreases will be used in order to enter into an orbit around the Earth. Because as you can imagine, the spacecraft will be traveling at a very, very high velocity as it travels through outer space. So in order to enter into an orbit around the Earth, it would have to slow down. Now you can see system number 2 at the top. It shows energy system. The energy system will be used in order to store energy and to provide energy to operate all the modules of the Mars orbital station. And then item number 3, again, you see it at the top. It says Mars lander. The Mars lander represents a combination of a lander, storage for tools and supplies, a rover, and the return vehicle. The use of each system involves an appropriate technology, concepts evaluation, manufacturer selection, design, prototypes of construction, and testing. Now here's the propulsion system. Let's expand on this. This system is formed by a module which contains propellant to feed two rocket systems. Each of these rocket systems has a main engine, secondary engines, and route correction engines. Inside is a propellant which is to be used by the secondary and correction engines. The main module has the computers and interfaces which are needed to control the engines. All right, let's take a good look at the energy system here. The energy system is formed by a module with solar panels, which can be extended and retracted, along with the capability to follow the sun. This module is covered with solar cells in order to capture solar energy and to store it in its internal batteries. In other words, this module is covered with solar cells in order to capture solar energy and to store solar energy in its internal batteries, to be distributed to all systems. The energy system will control its consumption of energy in such a way as to guarantee that there will be an available supply of energy for all the critical systems. All right, now let's talk about the Mars Lander Return Vehicle. This module is formed with a lander structure, which contains the return vehicle, a container for tools and supplies, and a roving vehicle container. This structure will provide a soft landing when landing on Mars. Once on the surface of Mars, this vehicle will open the tools and the rover containers. The central section will expose the crew compartment, and that compartment is the return vehicle. The MOS, or the Mars Orbital Station, has the Leonardo Multi-Purpose Logistic Module. This module will be loaded with supplies and parts. All of this material will be placed in an orbit around the Earth while the Mars Orbital Station is docked to the International Space Station. The crew will arrive at the ISS in one of the MOS docking vehicles. This vehicle could be a Soyuz, an Orion, a Dragon, Liberty, or some other vehicle. This vehicle will remain with the Mars Orbital Station structure for the return of the crew to the Earth's surface. One possibility could be the use of the Liberty crew and logistic model for this operation, using it as a return vehicle lifeboat, that's in quotes, lifeboat is in quotes, in case of an emergency. Also, an additional cargo vehicle can be sent to dock with the Mars Orbital Station to be taken on the journey as an additional supply module. The following sequence of slides illustrates the possible reconfiguration process of the ISS to create the MOS and the arrival of additional elements. This first one shows a schematic representation of the ISS and the selection of the modules that will become the habitational part of the MOS, including the separation of the structure of Destiny, Harmony, Kibo, and Columbus from Node 1. It will make a 90-degree rotation and redock with Columbus on Node 1. Tranquility is moved from Unity and docked to Destiny. Tranquility has a cupola and docking port, PMA3. This port is repositioned on Tranquility. The Leonardo multi-purpose logistic module is moved from node 1, that is Unity, to node 2, that is Harmony. This module will store supplies and spare parts for the voyage. On your right is the arrival of the energy module for the MOS segment. It is docked to node 2, and that is Harmony. This is a view from the front. Leonardo, remember, Leonardo is the multi-purpose logistic module. Leonardo is across from the energy module. Destiny and Tranquility are on the right. The crew will set up all the connections to distribute energy. In this view, now we're going to talk about the arrival of the Mars lander structure. In this view, the Mars lander structure is docked to the front of the Harmony node. At this moment, in this illustration, the landing pads are retracted. All right, here we can see an additional docking port has been attached to the Tranquility node. Now let's talk about the arrival and assembly of the Mars Orbital Station propulsion system. First of all, the main tank arrives, and the main tank node is docked to Tranquility. Then, each one of the engine units arrives to be assembled and connected to the main tank. A crew will arrive in the vehicle that will take them back to the Earth's surface at the appropriate time. This vehicle could be the Orion, the Dragon, the Liberty with the logistics module, or another vehicle which could be in development at the present time. At this time, the crew will be checking all of the systems, and supply vehicles will arrive. The crew will move the supplies and tools to the Leonardo module. If necessary, one of these vehicles can become a part of the MOS for additional supplies. Once all systems are verified, the MOS crew will move into it, and hatches will be closed and sealed. Tests will be performed, and before separation, all systems will be verified and checked. MCC, now MCC stands for Mission Control Center. Mission Control Center will give the go or the no-go. Mission Control Center will give either a go or a no-go for undocking when ready. This is the final configuration. This is the final configuration of the Mars Orbital Station. Now, in the next few slides, we will see a graphic representation of the journey to Mars, just to illustrate the idea and the basic concept of how this works. Once undocked from the ISS, that is International Space Station, the MOS, the Mars Orbital Station, will fire its main engines to leave the Earth's gravitational field. During the journey, all systems will be constantly checked. On Mars, the primary point of contact with the Mars Orbital Station will be the Mars Command Center. All communications from the lander will be to the Mars orbital station. The crew must be capable of making decisions and processing data whenever that is necessary. Mission Control Center will be uploading updates and software from the Earth. Once the approach to Mars has begun, the main engines will be fired to reduce speed and to let the MOS, Mars Orbital Station, be captured by the gravitational field of Mars. Maneuvers will be performed to adjust the orbit. During the orbit around Mars, the lander will be checked repeatedly before a landing attempt is made. The Martian weather will be analyzed. At the appropriate time, the lander will be undocked from the Mars orbital station, and then the lander will begin its descent to Mars. During the descent to Mars, rockets will be fired and parachutes will be opened. Once on the surface of Mars, the lander will open its central section and unveil the return vehicle. The return vehicle will be standing by for an emergency liftoff if that should become necessary. The tools and rover containers will be open, and the crew can begin the exploration of Mars. Once the exploration of Mars has been completed, the return vehicle will fire its main engine to take it back to the Martian orbit, where it will rendezvous with the Mars Orbital Station, or the MOS. The return vehicle will be docked with the MOS. The station will remain in orbit around Mars until the time comes for the journey back to the Earth. The main engines will be fired in order to leave the orbit around Mars. When approaching the Earth, the main engines will be fired again in order to reduce the speed and to allow the Mars orbital station to be captured by the Earth's gravitational field. Adjustments will be made to keep the Mars orbital station in orbit. The crew will return to the surface of the Earth in the return vehicle, and the return vehicle could be the Orion, the Liberty, or the Dragon, for example. The Mars orbital station will remain in orbit without a crew until it is used again. I hope that you have enjoyed this proposal. This concept represents a combination of existing technology and new and emerging technologies. Perhaps we will see a human presence on Mars during the course of our own lifetimes. Thank you for your attention, for your time, and thank you for your interest. I'm glad that you were able to join us for today's edition of International Definition. Today on International Definition, we watched a PowerPoint presentation which addressed the exploration of outer space. This presentation was prepared by an engineer named Miguel Cooper, or Mike Cooper. And you are invited to share your reactions to this presentation by contacting me here through this television station. This feature was presented as a part of the engineering tribute to the Presidential Inauguration of January 20th, 2013. And now, until our next broadcast, I'm your host, Kenneth Freelain, thanking you for joining us today.